Good evening, everyone. My name is Harini. I'm a PhD student in Interdisciplinary Center for Water Research at Indian Institute of Science, Bangalore. So currently, I'm doing NPTEL TA for the course Watershed Hydrology, offered by Professor Rajendra Singh sir from IIT Kharagpur. And in today's topic, we will be talking about droughts and different types of droughts that we experience and how to what are the indices that we use to indicate the droughts. Okay, so first let's look into the theory part and then go for the questions related to this. If you have any doubts in middle, you can raise your hand and speak, or you can message in the chat box if you are not able to talk. Okay, so first let's discuss what is drought. So, as we might know that we have heard the word drought a lot of times, but what is it like? If you don't have, if any region experiences a shortage of water or in any form, like whether it can be surface or subsurface form, if the water shortage is there, then for a prolonged period of time, then it is called as drought. Yeah. So, prolonged period during which a region experiences a shortage of surface or subsurface water. So, in some cases, what will happen if is we experience below normal rainfall over a significant area, and because of this, the economy, hydropower output, and agriculture, all these will get impacted. And because without water, we cannot do anything. We need water for drinking supply, for agriculture purpose. We do irrigation using water. And if there is no rainfall, we don't have any water that can be naturally given for the agriculture purpose. And through irrigation also, we cannot supply any water because already we are in deficit. And for hydropower output, we need water to get to generate electricity. So if there is no water for a significant period of time, then all these hydropower output, agriculture, and also because of this, the economy of the country, all this will get impacted. Okay. So this causes the degradation of water quality and quantity as well, which leads to a threat to environment and public health. So in India, around 16% of India's total area is drought prone, and 68% of total agricultural area in India is drought prone. Okay. So it is clear like there is a huge stress of drought on agricultural area. So that's why we will be discussing, focusing more on the agricultural drought. We will be looking into what is agricultural drought and what are the indices that we can use to quantify the agricultural drought. Okay. And also since India, we do major occupation is agriculture. So we will be looking into these cases also. So first, what are the causes of drought? So the first main cause of the drought can is like first main cause that we will get into our mind is the deficiency of in rainfall. Okay. So if there is insufficient rainwater during specific seasons or over an extended period, which this will lead to hydrological drought. Also, if there is no rainfall, we will see reduction in the water level in lakes, rivers, ponds, reservoirs, etc. So all these will contribute to a drought if it is prolonged for a longer period of time. So the second cause is dependency on rain-fed agriculture. So rain-fed agriculture relies on timely and sufficient rainfall for crop growth. If there is deficiency in rainfall already, then we cannot give irrigation for the agricultural land, which is mainly dependent on rainfall, right? So it will give, there will be a lack of water for crops, and which reduces the yield of the crop, or also it can lead to crop failure. So the next cause is over exploitation of groundwater reservoir resources. So all these from here on, these two are due to natural impact, and now we will be discussing causes due to humans. Okay. So over exploitation of groundwater resources is like if you are pumping out excess groundwater, even though you don't need, or like you are mainly depending on groundwater, that's why you are pumping excess water, then it will lead to the groundwater level depth going higher, so which will lead to lowering of water table. So we cannot extract more water further cases, and also if it happens in coastal areas, there is a chance of saltwater intrusion that can happen from oceans, as we have discussed in earlier classes. So also the next cause is land use leading to desertification. So, what does desertification means? The desertification means the fertile land becomes increasingly arid or unproductive, eventually transforming into desert-like conditions. So that is called as desertification. So once the land turns into desertification, then whatever water that is coming as rainfall also cannot be stored, and it won't be of any use because we cannot grow plants or trees in this kind of areas. So what we have to do is in such cases we should not practice like monoculture. So if you are cultivating same crop in every season, then what will happen is the nutrients in the plant, each type of plant will require this particular nutrients, right? So every season, if you're growing same type of crop, then all these nutrients will be extracted from the soil. So then, if you are again growing the same plant, then it won't even grow in the same area. So that's why what we have to do is like we should avoid monoculture and also excess use of irrigation, which will lead to soil salinization or poor soil management, like which will lead to degrading of soil quality and reduces its water retaining ability. So all these should be avoided to prevent the good land into converting into a desert kind of land. So the next one is deforestation. So, what will happen as we have discussed earlier also is suppose there is a forest area and then it is converted into deforested area, like the forest is cut down, then it will lead to 20 to 30% of excess runoff. So there will be an increase in the runoff about 20 to 30%. So that means like it is not able to hold the water in that particular area and it is running off, right? So deforestation will lead to changes in the disruption of the natural balance of ecosystems because of this change in the water cycle that is occurring in a particular area. So the next one is overgazing. So overgrazing means like when the vegetation is excessively consumed by livestock, then what will happen is it reduces the ability of the land to capture the water, capture and retain the water, right? So this also will be leading to drought condition if it is excess. Okay. So then next one is over cultivation. As the name itself suggests, if the continuous cultivation without any proper care or management we are doing, then it will lead to depletion of soil nature, and these kind of soils cannot support the growth of any other plants as well. So also then it will lead to less vegetation cover, and then which will finally impact the droughts. So these are the causes, and then let's look into the consequences when if we have a drought. So first thing is when you have drought, we don't have sufficient water in that area. So which will lead to diminished crop growth or yield reduction. And next, since the vegetation cover of the soil is reducing and the soil is becoming more and more drier, so if this kind of severe droughts can lead to dust bowls and dust storms. So, you know what is dust storms, right? So, dust bowls is like a region that experience severe dust storms due to the combination of prolonged drought, soil erosion, and poor land management practices. Okay. So, also, drought causes famine and habitat damage. So if you don't have water, then what will happen? Particular plants won't grow in the region. Then animals won't have enough sufficient food to rely on. So all this will lead to habitat damage. And also, since there won't be good crop yield and also plants won't grow, there will be hunger everywhere, which will lead to malnutrition, dehydration, and related diseases. Also, this can lead to mass migration of people or animals in search of food and water. Because even the drought also, it won't most in most of the cases we won't experience drought everywhere in the like if you are taking a country, the whole country won't be facing droughts. A parts of the country will have severe droughts. So in that case, what will happen is people or in animals will migrate to the areas where they can find this food and water, right? So migration happens, and there will be shortage of water, as I have discussed. So it will be a shortage for industries and domestic purpose as well. And there will be a fight over natural resources, including water and food. So now, so due to we have discussed about how what is drought and what are the causes of droughts, what is the consequences of the droughts, right? So what is the risk that is associated with the drought is what we are going to look now. So here, what does risk assessment means? So it is a process of identifying, quantifying, and ranking the vulnerabilities in a drought scenario. So we are in risk assessment. What we are going to do is we are trying to process the process of identification, quantifying, and ranking the vulnerabilities that we are facing in a drought condition. Okay. So what does drought risk means? It's a likelihood of incurring damages and economic losses during and after a drought. Likelihood of incurring damages and economic losses during and after a drought. So that's what we will see. Okay, so generally risk is a function of hazard, exposure, and vulnerabilities. So here, if you see, there is a agricultural drought risk, and first we will look into what is the hazard related to the drought and how much area or what kind of crop or what extent it is exposed to. So exposure also we will look into, and like who are the vulnerable, who are getting affected because of this. All these are important when we are trying to estimate the risk factor. So here, if you see, each what is hazard, exposure, vulnerability, overall risk, each and every term has a definition, characteristics, and what kind of data you need also is given in this table. So in the case of hazard, hazard is characterized by the magnitude of hydrometeorological deficit. So data will be like meteorological, hydrological, or biophysical indicators. Exposure is characterized as amount of elements and assets subject to a drought hazard. So here, what we will be looking into, what is getting exposed, right? So we will be looking into data we need is quantity and location of human population, infrastructure, economic activities, and or our ecosystem. So then vulnerability. Vulnerability is characterized as like sensitivity of exposed elements to damaging effects of droughts. So the data will be like composite indicator that includes social, economical, environmental, and or infrastructure components. So overall risk will be the characterized as potential damages and losses from droughts to a specific asset. So here we will be measured in probabilistic scale as a combination of drought magnitude or severity, level of exposure, and vulnerability. Okay, so now let's look into what are the main variables to characterize drought events. So here we have like many variables. So we will be looking into each of them now. So first one is frequency. So frequency is defined as the number of drought events per defined time interval. Suppose in 1 year, how many droughts are occurring? So if there are 10 droughts that are occurring, then we are saying that the frequency is 10. Okay. Then we have a term called variable called severity or magnitude. It is related to water deficit and we have an equation for that. The severity is given as sigma Ti minus threshold. So Ti is a drought indicator. We will be discussing about different types of drought indicators. And threshold is the level of dryness that we are specifying for an area. It depends on the area or the climate because so in some areas Rajasthan, the dryness threshold for the Rajasthan will be different compared to any place in Hyderabad or Bangalore, right? So this threshold will be dependent on location also. So based on that we'll set a threshold and we can calculate the severity of the drought using this formula. Then deficit of water. Next variable is intensity of drought. So it is defined as severity divided by duration of event. X duration, onset. So when did the drought started is called as onset. Then cessation is like when the meteorological indices have returned to normal. It's called as cessation. That is like there is a the drought has ended. Then we have endpoint where the conditions are coming back to pre-drought period. Okay. Then we have peak month or day, which will be the day which will give us an idea of a day or month with the lowest value of drought indicator. If there is a lowest value in drought indicator, that means there is a the drought is very severe in that particular month or a day. The next one is area affected. So area with values of drought indicator below a certain threshold is considered as the area that is affected for because of drought. Okay. Now let's look into steps involved in drought risk assessment. So the first one is we have to first define the scope and objective. Then we have to assemble a diverse team because if there is only hydrology, it won't work because we have to know how it will impact every sector, like how it is impacting agriculture, what are the changes that is happening in climate, which is leading to drought. So different types of background people we need for the drought risk assessment. Then we have to collect historical data. So these like we have to identify drought indicator or trigger. So based on what is the scope and objective of your work, then you will be identifying which type of drought indicator is more suitable for your study. So then define vulnerable sectors. Okay, then we have to develop a monitoring system, then conduct susceptibility assessment. So we have to model different scenarios and analyze them because we cannot wait in real time for that particular scenario to happen. If we do that, we have if we can have a model ready and then run different scenarios. We know like what can be the severest like drought, severest drought that a particular area can take, and what can be the mitigation measures that are more suitable for the particular scenario. All this analysis we can do using the models that we have developed. Then we have to engage the community who are staying in the particular location, and then we have to have a risk mapping. So identify the areas which are drought prone areas. So we have to map them so that we will be applying these immediate measures for long term, either for long term or short term, immediately if you do to drought for that particular areas. Okay. And we need to have a early warning systems also for the particular areas. Okay, which are under pressure. Then then we have a different type of drought classification. So if you see here, classification. If you see here, as you go from top to bottom, if the drought is progressing for a longer period of time, there are different types of droughts that we experience. So first, initially, for a shorter, if the drought is for shorter period of time, we will be experiencing meteorological drought. In that case, what is happening? There is a reduction in rainfall, increase in temperature, reduction in cloud cover, wind speed is increasing, relative humidity is decreasing, sunlight is increasing. All these are the characteristics that, like, all these will be happening. And because of them, what is going to happen since since rainfall amount is low, there won't be infiltration reduces, even the surface runoff reduces, which will also lead to groundwater recharge decrease, and there will be higher evapotranspiration because of higher temperatures compared to normal. So if this drought prolongs for some longer period of time, then it can cause agricultural drought. That means there is because there is no water that is available for plants, because there is a less amount of rainfall, which is leading to less amount of water getting infiltrated into the soil, and also there is decrease in groundwater recharge, which will cause there is no which will lead to in a unavailability of water for plants. So it will cause plant water stress. Okay, so there will be a reduction in soil water, and if the drought still prolongs for a longer period, then we will experience a hydrological drought. So hydrological drought is whatever the hydrological cycle process that we have seen. All there in all these systems, there will be a reduction in the water level. So suppose the groundwater level decreases, even in reservoirs also the water level decreases, or the amount of water coming into the reservoir is decreasing, and the stream flow level in the rivers is decreasing. If you see here we are talking about there is a reduction in the water level in reservoir, lake, tank, and water. So if there is a reduction in water level in the water bodies, then it is a hydrological drought. So if the drought still prolongs for a longer period, then it causes socio-economic drought. So because of this, all the droughts that we are experiencing, like meteorological drought, hydrological drought, agricultural drought, which will lead to unavailability of water for agriculture purpose, for industrial purpose, for everything. So which will and also for drinking purpose also, there won't be enough water, enough quality or quantity of water we will have. So this means it will finally impact the economy of the country, also the environment and social impacts will be there because of this. So first, since I have talked about different types of droughts, we will look more into each of the drought. Okay, first we will be looking into meteorological drought. So in this, if there is more than, let me share my screen again. Yes. So, what is called as meteorological drought? If there is more than 25% decrease in precipitation from normal, over an area is called as a then we will consider it as meteorological drought. More than 25% equivalent rainfall from normal over an area is called as. So here precipitation, rainfall, instead of precipitation, it should be, sorry, instead of rainfall, it should be precipitation. Any form of precipitation, if there is reduction in more than 25% of it compared to normal, then the area is under meteorological drought. So there are still sub classifications like there is a normal drought if the total seasonal rainfall is less than 75% of normal, and there is a moderate drought when total seasonal rainfall is in between 26 to 70, sorry, 50%, and there is a severe drought when total seasonal rainfall is less than 50% of normal. So when there is, if there is a total seasonal rainfall that is happening is less than 75% of normal, then it is called as normal drought. If the total seasonal rainfall deficit is in between 26 to 50%, then it is moderate drought. Okay. So if the total rainfall, seasonal rainfall is less than 50% of normal, then it is called as severe drought. Okay. So also there are other terms like drought year. So drought year is like if there is more than 20% of total area of country gets affected by moderate or severe drought, then it is considered as drought year. Okay. So next term is drought prone areas. So the probability of a drought occurring in the area is in between 0.2 to 0.4, then it is considered as a drought prone area. There is another drought called chronically drought prone area. So in this, the probability of a drought occurring will be greater than 0.4, then it is called as a chronically drought prone area. So now let's look into the what are the causes of meteorological drought. So here we have different causes. Like one of the main cause is there is insufficient rainfall, and also so there is insufficient amount of rainfall. Insufficient rainfall. Then there will be climate variability like El Nino, La Nina, where El Nino means like the conditions will be drier than normal conditions. So if El Nino is happening worldwide, then most of the areas will face drier conditions than normal. Okay. So this is a natural climate variability that is happening. Then we have global climate change. So because of climate change, the temperature is increasing and which will cause to higher evapotranspirations that is happening and in some areas we are facing reduction in precipitation as well. So all these are the causes of meteorological drought. And then we have local topography and geography. So in this case, like if you see, naturally there are areas which are rain shadow regions. Like suppose one side of the mountain will be facing huge amount of rainfall, but on the other side it will be a rain shadow region, which is leeward side of the mountain. So in those cases, there will be naturally a drought will be occurring. And the natural climate variability, which is occurring in long term climate cycles. And also, there are like anthropogenic influences, which are like land use changes, etc. These are leading to meteorological droughts. Okay. So now let's look into how to identify these meteorological droughts. We have different indices. First index is deciles of precipitation. So it is calculated using the long-term monthly rainfall records. Firstly, what we will do is we will take the historical data and then arrange it into order ranked from highest to lowest, and then we will calculate cumulative frequency distribution. So once the distribution is constructed, we'll split it into 10 equal parts based on the probabilities, and the drought severity is then categorized based on the deciles. So if you see here, the monthly precipitation decile values are given, and if the based on the value that we are getting, if the deciles value is 80%, then we say that much below normal rainfall is happening. So if it is suppose if it is 88%, then it is much above normal rainfall happening. So there is no drought. So based on these decile values, we will know whether there is a meteorological drought occurring or not. So there are various advantages and disadvantages related to it. So first advantages are deciles index provide accurate precipitation data for drought response, and it is useful in assisting decision makers. So the disadvantage is we need a long climatological record of the data. If the data is not required, then we cannot form a proper cumulative distribution. So it won't be that much accurate. So then we have one more index called precipitation departure from normal, PDN. So this is calculated by the formula PDN is equal to P naught minus long-term mean of precipitation at a station by long-term mean of precipitation at a station into 100. P naught is the precipitation at the current time step. Okay. So once you calculate this and the value is like based on the PDN value, we have classified the severity of the drought. If the value is 0 or more than 0, if it is positive, then there is no drought. If it is negative, then there is a drought, but the severity of the drought is like suppose if it is 30%, then there is a moderate amount of drought. If it is, sorry, minus 30%, moderate drought is there. If it is minus 75 or if it is more than minus 50%, then there is a severe amount of drought. So the advantage of this method is it is very simple because we just have to find long-term mean and then the calculations are very simple. But the disadvantage is like distribution or time scale of rainfall is not specified in this case. So the third indicator is standardized precipitation index, SPI. So this is the mostly used index worldwide. So it is developed by McKee in et al. In 1993. And here, what we are doing is 30 years of continuous monthly precipitation data is required. And for that data, we have to fit a gamma distribution function. So we have discussed different types of distribution like normal, exponential, right? So in this, for calculation of SPI, we are fitting a gamma distribution function. And if we are calculating SPI for short time scale, then the SPI is mostly related to soil moisture deficit. If we are calculating for longer time scale, then SPI is related to both the groundwater and reservoir storage. So the advantage of this method is that, as I've discussed, like we can calculate for different time scale, like short time scale, longer time scale. So the advantage is it can be computed for different time scales, and then we can provide a early warning for drought. So the disadvantage is that the temperature part is not taken into account when we are calculating the standardized precipitation index. So the formula used in SPI calculation is P minus P bar by sigma. P is the precipitation at the station. P bar is the mean of the precipitation data at the station. And sigma is the standard deviation of the precipitation data at the same station. Okay. So based on the SPI value, we are doing classification. So if you see here, if the SPI value is less than 2 minus 2, then there is an extreme drought that is occurring at the station. If it is between minus 0.9920, then there is mild drought. If it is positive value, then it means there is no drought at all in that area. Okay, so till now we have discussed about drought, what are the causes, consequences of droughts, variables involved, and first we have looked into what is the meteorological drought and how we can calculate it using the three types of drought indicators. So the first question is, what are the causes of droughts? Option A, deficiency of rainfall. Option B, dependency on rain-fed agriculture. Option C, deforestation. Option D, all of the above. So we have discussed that all these causes droughts. So the answer is option D. So the next question is, what are the consequences of droughts? So because of droughts, we have seen there won't be enough water, sufficient water, so there will be diminished crop growth or yield reduction. And because the soil is becoming drier, it can lead to dust storms, dust bowls. And since there is diminished crop growth, there will be hunger involved. So the answer is all of the above. So the next question is, in India, a meteorological subdivision is considered to be affected by moderate drought if it receives a total seasonal rainfall that is. So if you remember, we have discussed this question. If the deficit is between 26 to, so we have discussed that if the total seasonal rainfall deficit is in between 26 to 50%, then there is a moderate amount of drought. So if the deficit is 26 to 50%, then the total seasonal rainfall will be 50 to 75%. So option B. Okay, C. Then the next question is, an area is categorized as drought prone if the probability of drought occurrence is. So if you remember, we have two types of terms, drought prone area, and also another term is chronically drought prone area. So in that we have seen that if the probability of drought is in between 0.2 to 0.4, then it is a drought prone area. And if it is more than 0.4, then it is a chronically drought prone area. So the option is option A. The next question is the standardized precipitation index based on the probability of precipitation for any time span. So we have written formula SPI is equal to P minus B bar by sigma. P is the precipitation at the station and P bar is the mean precipitation. Sigma is the standard deviation. So the answer is option B. So now let's look into different types of hydrological droughts and socio-economic droughts. Hydrological droughts. So as we have discussed, like if there is below average level of water in stream flow or there is a reduction in storage in tanks, reservoir, groundwater and soil moisture. So that is leading to hydrological droughts. There are different components in the hydrological drought. First one is magnitude, duration, severity, and frequency. All these are different components to define the hydrological drought. So also methods involved in studying these surface water deficits are like low flow duration curves. We have discussed about flow duration curves, right? So in this case, drought is mainly due to low flow events. We will be concentrating on low flow duration curves. And second method is low flow frequency analysis. And third is stream flow modeling. Using stream flow modeling, if we know the amount of rainfall that we are receiving, and based on that we can generate stream flow using the models, and based on the stream flow values we know whether there is a hydrological drought occurring at a place or not. So also that like what are the causes of these droughts are like first one is natural variability, second groundwater, groundwater over exploitation, extraction or exploitation. Third one is human water management. Fourth is temperature extremes. So the next one is like we have seen what is hydrological drought, and now we will look into hydrological drought indicators. So the first one is standardized water level index, written as SWI, and it is used to mainly assess this groundwater recharge deficit. SWI is given as Wij minus W bar by sigma, where Wij is the seasonal water level for ith well and jth observation, and Wi bar is the seasonal mean, and sigma is the standard deviation. And based on SWI value, we have different classes. If it is greater than 2, then there is a severe drought, extreme drought that is occurring. If it is greater than 0, then there is a mild drought. That means in between 0 and 1, then there is a mild drought that is occurring. So the main advantage of this method is like for it can be computed for different time scales, and early warnings of water storage can be given. So the main disadvantage is that only groundwater is taken into account when you are calculating this index. So the next index is surface water supply index, SWSI. So it integrates both all these terms like reservoir storage, stream flow, snow, and precipitation into a single index. So SWSI is equal to A into P snow plus B into P precipitation plus C into P stream flow plus D into P reservoir minus 50 by 12. So here, one more check we have to do is A plus P plus D is equal to 1. And PI is the percentage of non-exceedance for each of the four water resources. So if here P snow is the percentage of non-exceedance for snow water resource, like that we have to calculate the probabilities for each category. Then we can calculate SWSI, and here is the table that shows like what are different values of SWSI, what are the drought classes that are classified. And the advantage of this method is that a full water resource of basin is taken into account. We are involving terms like snow, precipitation, stream flow, reservoir. All these terms are involved in this. But the main disadvantage is it is unique to each basin, so we cannot do comparisons, and changes in it also changes when there is changes in water management within a basin. Okay, so if you see here SWSI value is less than 2%, then there is an extreme drought event. If it is like in between 26 to 50%, then there is a mild drought event. That means if it is greater than 50%, there is no drought that is occurring. So the next indices is reclamation, drought index, RDI. So it is mostly done at a river basin level and has water demand and temperature components. So generally the variables involved are temperature, precipitation, snowpack, stream flow, and water level, reservoir levels are the inputs. And the main advantage of this is it takes temperature effect on climate is included, and they have wet and dry scales allow for monitoring of wet and dry conditions also. There are disadvantage is that it is a individual basin calculation, so basin calculation, so we cannot do comparison between a comparison of RDI values in between the basins. Also, if there is a the data availability delay the analysis, because since we need lot of data, if there is a delay in the data that is coming for us, then there will be delay in the computation also. So based on different RDI values, we have different classes here shown in the table. So if it is in between 0 and to minus 1.5, there is a normal to mild drought. If it is greater than 0, that means positive values, then there is no drought. So if it is less than minus 4, then there is an extreme drought event that is occurring. So next is that we are looking into socio-economic drought. So here if you see, they have defined socio-economic drought combines aspects of agricultural, hydrological, and meteorological drought with the supply and demand of a particular economic good. So it is a situation when the demand for a economic good exceeds the supply as a result of a weather-related shortage in water supply. So, so for example, if we take there is no rainfall, so because of that we could not produce onions, which but the demand for the onions is higher. So then what will happen? The prices of the onions will go up. So this is called as socio-economic drought. It's impacting the economic of the country, right? So then the process of supply and demand in terms of time and space determine when droughts occur and how severe they can become. Okay, so what are the causes of socio-economic drought? Is first one is population growth, Second is water mismanagement. Third one is inadequate policies. Okay, so now we have looked into hydrological drought and socio-economic drought. So before going into agricultural drought, let's look into questions related to these two topics. So what are the different types of hydrological drought indices? Option A, standardized water level index. Option B, surface water supply index. Option C, reclamation drought index. Option D, all of the above. So remember, all these are the indices for hydrological drought calculation. So from here, all these are agricultural drought. So let's look into agricultural drought. So, agricultural drought is defined as there is a prolonged period of insufficient moisture in the form of precipitation or soil moisture that is affecting the crop yield or and production is termed as agricultural drought. So, here what will happen is there is precipitation, precipitation, shortages, difference between actual and potential ET, soil water deficit, reduced groundwater, and reservoir levels. So all these happen when there is an agricultural drought, and the time scale for water deficit is shorter than hydrological drought cases in case of agricultural drought. If you remember in the slide previously, as we go down, the time scale of the drought is increasing. So the it is going further into from meteorological drought, it is leading to agricultural drought, hydrological drought, and then into socio-economic drought. Right. So the time scale of agricultural drought is shorter than hydrological drought. So now let's look into different types of agricultural drought indices. First one is aridity index, AI, which is computed as AI equal to ET naught minus ETA by ET naught into 100. ET naught is potential evapotranspiration. ETA is actual evapotranspiration. Generally, this ETA is calculated using lysimeter. So if we don't have a lysimeter at a particular location, we can use any kind of evapotranspiration equations like count weight, okay, Penman, etc. to calculate the actual evapotranspiration. So what does this aridity index mean? We have written the equation, but what does it mean? It gives us the degree of dryness of a climate at a given location. So it is mainly useful in shorter time span, like weekly drought determination case. And if there is a departure of this aridity index from its corresponding normal value, and then it is called as a aridity index anomaly. So which represents the water moisture storage shortage. Okay, so AI, that is aridity index, represents crops potential moisture, stress. So here if you see based on the values of AI values, there are different classes of drought. If it is less than 25%, then it is a mild drought. That if it is greater than 50%, then there is a severe drought that is occurring at the location. So they now we will be now I'm told that if there is lysimeter is not available at a particular location, we can use town weight equation, water balance equation to calculate the ET values, actual evapotranspiration, that is given in 1.6 LA into 10 T bar by 10 into T bar by IT whole power A. A is a empirical constant which is calculated using formula 6.75 into 10 power minus 7 IT cube minus 7.71 to 10 power minus 5 IT square plus 1.792 into 10 power minus 2 IT plus 0.4939. So this is A is empirical constant and is calculated using this. T bar is the mean monthly air temperature in degrees Celsius, and ET is evapotranspiration in centimeters per month, and IT is a total of 12 monthly values of heat index, and LE is adjustment for number of hours of daylight and days in a month related to the latitude of the place. So we have the advantage of this method is easy computation, and the because only inputs are precipitation and temperature. So the main disadvantage is that there is a crop water requirements are not considered in this method, and also doesn't take into account the carry of over dryness. So also it may be slow to react in certain climate. So next one is Palmer drought severity index, TDSI. So it is mostly used to identify the agricultural droughts, and here we are taking monthly time scale. Variation in moisture are observed using this. So TDSI is calculated using formula C1 into ST minus 1 by C2 into sigma of T equal to 1 to N RT plus C3 into ST minus 1. ST is the current moisture supply, RT is the runoff, and ST minus 1 is the previous time step water supply, moisture supply. And C1, C2, C3 are coefficients which are dependent on regional conditions. So also for computation of the specified softwares are used. And since whatever PTSI we are calculating is correlated with the soil moisture and stream flow in low and middle latitude, so this index can be used for identifying droughts in soil moisture and stream flow. So the advantage of this method is that it is widely used for agricultural drought conditions and provide a long-term perspective on agricultural drought condition. The disadvantage is a lag in detection of drought over season and several months. So here, based on the values of PDSI that we are calculating, we can classify the severity of the drought. So if it is between -1 to -1.99, there is mild drought. If there is more than minus, it is more than -4, extreme drought. If it is like less than -1, that means there is no drought that is occurring on the location. So the next one is moisture adequacy index, MAI. So it is calculated as MAI is equal to actual evapotranspiration by potential evapotranspiration into 100. So it is developed by ICAR, Central Arid Zone Research Institute, in in Jodhpur, India. So here what they are doing is weekly water balance and better in assessing the degree of adequate rainfall and soil moisture to meet potential requirements of the crop. So it is developed India. So it is mostly mainly applicable for Indian regions, more suitable, I would say. So for large areas, soil water balance approach is used to calculate the AET. PET we can calculate as we have seen in earlier studies. So AET only we have to calculate either by observations or from water balance approach, soil water balance approach, or using temperature as input. So the advantage is that the water balance calculations takes into account of soil characteristics, crop growth period, and water requirements of major crops. So also the one more advantage is drought is specified for crop wise on real-time basis in this case. The disadvantage is that we need lot of data for this computation. So calculations are data intensive. The next one is crop water stress index CWSI. So CWSI is calculated as sigma planting till harvesting 1 minus TA is the actual transpiration, actual crop transpiration, TP is the potential crop transpiration into WSUS. WSUS is the seasonally dependent weighing factor for grain yield susceptibility. So it's mainly used to explain the degree of crop water deficiency based on canopy surface temperature, ambient air temperature, and soil water dynamics. So if you see here, if the value is closer, CWSA value is closer to 0, like less than 0.5, we assign the value as 0. And that means there is an extremely wet or no stress condition that is occurring. If the value is closer to 1, we assign it as 1. So here that means there is an extremely dry or no transpiration condition is happening. Okay, generally for to calculate a CWSI, we use the software SPAW, that is soil, plant, air, water model is used for computation. So the advantage is that it estimates using dynamic simulation models, and their performance is reasonably good. And the disadvantage is this PA model calibration has to be done for each crop and at each region. So that is means it will take a lot of time for setting up the spawn model. So now let's look into questions related to this before going into the indicators, agriculture drought indicators that we can develop using remote sensing data. So the questions are: agricultural droughts are triggered by dash and hydrological drought. Option A, climate change. Option B, reduced rainfall. Option C, meteorological. Option D, reduced production. So hydrological agricultural droughts are triggered both by meteorological and hydrological drought. That means we see reduction in precipitation, also reduction in water levels in the water resources like rivers, reservoirs, etc. So then the aridity index, where AET and PET being actual and potential evapotranspiration, is given as. So if you remember, aridity index is calculated as PET minus AET by PET into 100. So the answer is option A. Next, the moisture adequacy index AET and PET being actual and potential evapotranspiration is given as option E 100 into AET by PET, option B 100 into PET by AET, option C 100 into PET minus AET, option C 100 into PET plus AET. So here MAI is defined as AET by PET into 100. So the option is option A. So if the MAI, soil moisture adequacy index of a particular area is 58%, then what should be the drought condition of the area? So for this, let's look into the table related to MAI. So here if you see, this is the table. Okay, if the MAI value is 58%, that means it is lying in this zone. So that means the drought class is mild drought, right? So option B. Now let's look into the different types of indices that we can develop for agricultural drought using remote sensing data. So the first one is in that NDVI, which is called as normalized difference vegetation index. NDVI. So it uses visible and near infrared bands and it assesses the greenness in the vegetation cover. So the advantage is that monitor it will help us in monitoring vegetation growth and health. The disadvantage is if there is crowd cover, we cannot get the remote sensing data. So we cannot calculate NDVI and in turn the greenness of the vegetation. So NDVI is calculated as NAR minus R by NAR plus R. So NAR is the here we are talking about reflectance in the near infrared region and red bands. Okay, NAR represents the reflectance in near infrared region. R represents the reflectance in red band. Okay. So using the reflectance value, we calculate the NDVI values. Generally, NDVI ranges from -1 to +1. So the variation in NDVI for different crop growth periods will give us an idea of how healthy the vegetation is. So if there is a healthy vegetation, then what is happening is it will reflect more NIR and it will absorb uh, red band. So there will be low reflectance. So for healthy vegetation, NIR will be higher and reflectance in red will be lower. So that means NDVI value will be higher. So if you see here also, as the value is increasing, then the drought is becoming that means there is no drought. Okay, so if there it is greater than 0.1, then it is called as above optimal. If it is less than -0.2, then there is a severe drought that is occurring. So the next index is transformed vegetation index, that is called as TVI. Okay, so it is a modified form of NDVI and it is useful in assessing vegetation conditions under water stress or drought conditions in agricultural areas. So it is sensitive to changes in both leaf area and chlorophyll content, and TVI is given as root of NDVI plus 0.5. That means root of NAR minus R by NAR plus R plus 0.5. The range is between 0, 1.2 for TVI, and the main advantage of this is it is less sensitive to atmospheric conditions compared to other vegetative indices and is used in accordance with other vegetation indices because not like only one vegetation indices will not give us a clear idea about how the health of the vegetation is. So we generally we generally take into account multiple vegetation indices for our better understanding. So the disadvantage because of this method is it may not be sensitive to early stages of stress in vegetation, and based on the angle of sun and presence of shadow, the TVI calculations will get impacted. affected. So these are this is a table which will give us an idea of what is the TBI range and what are the classes, corresponding classes based on the TBI value. So the next one is enhance vegetation index is AVI. So by reducing these atmospheric impacts and decoupling the canopy background signal, EBI is developed and it is widely used in precision agriculture. That means when we need precise answers in agriculture, then we use this index and it is used to identify fields that experience drought stress, nutrient deficiency, and or other issues. So EBI is equal to G into NAR minus R by NAR plus C1 into R minus C2 into B plus L. So generally this is for this the data is obtained from MODIS satellite. B is near blue region, near blue band. G is the gain factor. C1, C2 are the quotients, and L is the canopy background adjustment factor. So mostly here in this case, atmospheric corrections are partially or wholly done, and L addresses the nonlinear differential NIR and red radiant transform through a canopy. And C1, C2 will take care of the aerosol resistance term, which uses blue band to correct aerosol's influences in red band. MODIS, for MODIS, the EBI algorithm, the the parameters are L equal to 1, C1 equal to 6, C2 equal to 7.7, and G equal to 2.5. So if you are getting data from MODIS, we can just take these values for the parameters and calculate the EBI value. And based on the EBI value that we have obtained, there are different classifications for the drought. If it is if the EBI within the standard deviation of baseline is plus or minus 1, then it is normal range. If it is more below minus 3, then there is severe drought. So how are we saying that here what we are trying to do is we are doing standard deviation based on a baseline. Okay, so how are we doing that? So baseline values are developed from the historical data. So the historical data without any drought stress are taken first, okay, and based on that some baseline value is calculated, and then the anomalies is nothing but the current value minus the mean. So that will give us, if we divide by standard deviation also, sometimes we divide by standard deviation, then that is called as anomaly. Based on the S anomaly values, then we are classifying the drought classes for EBI. Next one is vegetation condition index, VCI. So VCI is calculated as VCIJ equal to NDVIJ minus NDVI minimum by NDVI maximum minus NDVI minimum into 100. There is a power cut. Just let me connect to the hotspot. I hope everyone can see the screen. So this is how we will calculate the VCI value, vegetation condition index, and So vegetation. Okay. So I hope now my screen is visible. Let me reshare the screen. Okay. So now we are talking about VCI, Vegetation Condition Index, which we are calculating like using the formula NDVI minus NDVI minimum by NDVI max minus NDVI minimum into 100. So NDVI is the NDVI for jth month or week, and NDVI minimum is the long term. For example, like 20 years, etc. Okay, you can take 20 years, 25 years, but minimum should be 20 years. The long term minimum NDVI for the jth month or week is the NDVI minimum. Similarly, NDVI maximum is the long term maximum NDVI for jth month or week. And if the VCI value is 0%, then it means poor vegetation. If it is 100%, then there is optimum vegetation, and it mainly focuses on impact of drought on vegetation and provide info on onset, duration, and severity of the drought. So the advantage of this method is high resolution and good spatial coverage used for crop yield forecasting, and also it can be used for long-term monitoring of vegetation health trends. So the main disadvantage is it is limited to number of bands used, but so that because with if we are using less number of bands, we cannot differentiate different with all the vegetation types that are available. So if that's the main disadvantage of this method. And based on the VCI values, the drought classes are given here. If it is less than 10%, it is extreme drought. If it is greater than 50%, then it is a wet condition. That means no drought. So the next one is temperature condition index, TCI, which is calculated as TCI max equal to BT max minus BTJ by BT max minus BT min into 100. BT is the brightness temperature for jth month or week, and BT max and min are the long term maximum and minimum for of brightness temperature for jth month or week. So long term means we have to take minimum of 20 years. Okay. So in this, stress on vegetation caused by temperature and excessive wetness is considered. So the main advantage is it will provide an early warning system for potential crop stress, and also it helps us in understanding of vegetation response to both temperature and moisture condition. The next advantage is it is applied for seasonal monitoring of temperature conditions. So the main disadvantages of this method are variation in atmospheric conditions affect the signals. This is the main drawback with all the indices that are related to remote sensing. And the other main disadvantage is surface characteristics can influence the land surface temperature, like surface characteristics like soil type and moisture conditions. All these will influence the computations. So here, if you see, the values are also given based on the values, the drought classes. If it is 0, TCA extreme drought class. If it is closer to 1, then there is no drought. That is optimal condition that is happening. Okay, the next one is difference vegetation index, TVI. So dBi is calculated as NAR minus red, that is reflectance in near infrared region, minus the reflectance in red band. So it is the simplest and is used to assess the vegetation health and monitor changes in plant cover over time. So easy, like modified cameras and GoPros also can be used for getting the data. So it's very simple. So, but the advantage of this method is sensitive to vegetation changes and very simple calculations. But the main disadvantage is it's sensitive to atmospheric conditions. It is susceptible to soil background influences. And so the next index is soil adjusted vegetation index, SAVI. So SAVI is calculated as NAR minus red by NAR plus red plus L into 1 plus L. So L is the amount of green vegetation cover. So it basically uses a soil brightness correction factor. So when if there is very high vegetation cover, L is equal to 0. If there is no vegetation cover, then L equal to 1. L equal to 1 means no vegetation cover. If there is moderate vegetation cover, then L is equal to 0.5. Then the advantages are there is reduced soil background influence and improved accuracy in high vegetation cover areas. So the disadvantage is that there is a dependency on soil adjustment factor. So we have to do an accurate computation for soil adjustment factor and it is sensitive to soil type. So the next index is visible atmospheric resistance index, VARI. So it uses RGB based, it is based on RGB, red, green and blue bands. The crop index is calculated and it reduces the atmospheric effects by subtracting blue wavelength from green and red. Okay. So R is equal to R green, reflectance in green band minus reflectance in red by reflectance in green plus reflectance in red minus reflectance in blue. So by subtracting this, the atmospheric effects are reduced. So the advantage is it is sensitive to vegetation health and it minimizes minimization of atmospheric effect because of the blue band subtraction. And the disadvantage is it is sensitive to atmospheric condition. Like if there is cloud cover, we cannot get the data. And there is a dependency on specific sensor characteristics. So the next one is green vegetation index, GVI. So GVI is calculated as minus 0.2848 TM1 plus minus 0.2435 into TM2 plus minus 0.5436 into TM3 plus 0.7243 into TM4 plus 0.0840 into TM5 plus minus 0.1800 into TM6, where this TM1 to 6 are the can be obtained from a Landsat TM bands or ETM plus and Landsat 8. Okay, generally the GVI values will range from -1 to 1. And the advantage is the correlation with the ground truth. It has high correlation with ground truth data and also simplicity and ease of interpretation. So the disadvantage is the lack of sensitivity to specific vegetation stress factors. Also, there is over reliance on green brand in this case. So the next topic is drought manage. So, in case of drought management, first what we are trying to do is we are trying to identify the areas which are under drought, and then we will try to apply some methods like mitigation measures or early warning systems for short term and long term goals to reduce the impact of drought in this area. So, they have a term called drought proofing techniques. What does that mean? It means that immediate support for drought affected areas and long term resilience and preparedness measures that we are applying for the particular area. So the steps involved in this is creation of water storage, interbasin transfer of water, surface water, development and management of groundwater potential. Next, development of appropriate water harvesting practices, in situ soil moisture measurement measures. The next one is economic use of water. Next one is reduction of evaporation from soil and water surface. And next one is afforestation, agroforestry, and agro-horticulture. So all these are the techniques that we can use in drought-proofing techniques. So also like to prevent for drought management, we have different methods like uh, cloud seeding, evaporation control, water harvesting. So we have seen like we have known like recently also in Dubai this happened seeding. So where we are aiming to change the amount or type of precipitation by artificially forming the clouds and making the clouds give us rainfall. So for that we are using some chemicals which are commonly used in practice as silver iodide, potassium iodide, dry ice. So mostly we use silver iodide because it won't be affecting the health of animals or human beings because finally the water will be coming down. So they will be bringing the chemicals also down, right? So then there are evaporation control measures like floating covers and shades and also wind breaks, which will reduce the wind flow in the area. So if there is less wind flow, then that means evaporation is less. Then water harvesting, like so we have talked about water harvesting. Like sir has discussed different ways in different scales we can do water harvesting. In at home also we can do in micro scale like in small patches of lands we can do water harvesting, and also for like large areas also we can do water harvesting is nothing but mainly whatever rainfall that we are getting, we are not letting it flow as runoff. We are mainly making the water getting infiltrated into the soil or getting stored into some reservoirs or storage structures that are available like lakes, ponds within the basin. Okay. So mainly we will collect and store the water within the basin without letting it flow into other parts. So if there are any questions, you can ask me, or we will just solve few problems related to this topic now. So the first question is NDVI stands for. We have discussed that the NDVI full form is Normalized Difference Vegetation Index. So option C. Next one is an agricultural drought can occur if there is option A, early onset of the monsoon. Option B, there is no gap between rainfall events during the season. That means there is good rainfall, so there won't be any drought. Option C, early withdrawal of monsoon. Option D, sudden heavy rainfall. Sudden heavy rainfall, early onset, this won't be any problem. But if there is early withdrawal of monsoon, so there is not a sufficient rain within the area, which will lead to agricultural drought. So crop water stress index is computed using which software? SWAT, SPA, species swim, none. So if you remember, we use SPA, soil plant air water model to calculate the CWSI. So the next one is the most common chemical used for cloud seeding is option A silver iodide, Option B, silver nitride. Option C, potassium iodide. Option D, liquid nitrogen. So we use both silver iodide and potassium iodide, but most commonly used in practice is silver iodide. So here they are asking us, like, utilizing the information from the lysimeter, find the aridity index once a peak. So here aridity index is defined as PET minus AET by PET into 100. So they have given the values of PET and AET. So if we calculate that, so I'll show it for the first row. So PET is 3, AET is 2 by PET is 3 into 100. So that is 1 by 3 into 100, which is equal to 33.33 percentage. So based on this, for every week, we will calculate the aridity index. Once you calculate it, we will get values like this. And based on the table, so if the for first row, the value is 33.33, so it is lying in this zone. So that means there is moderate drought. So similarly, for each row, we have calculated, and based on where the value is lying, we can classify it to mild, moderate, or severe drought, and this classification is made. So the next one is calculate the Palmer drought severity index using the following information. So they have given current moisture supply, runoff, previous moisture supply, and the quotient value. So how do we calculate PDSI? So PDSI formula is C1 into ST minus 1 by 2 into sigma of T equal to 1 to N RT plus C3 into ST minus 1. So PDSI is calculated as C1 is 0.8 into ST is current moisture supply 0.3 minus 1 by C2 is 0.3 into runoff is 0.15 plus 0.25 is C3. ST minus 1 is 0.25. So once you calculate this, you'll get a value of minus 0.09. So if you see, look into the table where PDSI values are used to classify the drought severity. So minus 0.09. So the value is starting from, for mild drought, it is minus 1 to minus, almost minus 2, right? So the value is less greater than that. So this will be like no drought condition. It's not lying within in any of the interval given in this table. So that means there is no drought that is occurring in this particular case. So the next one is find the actual crop transpiration for the month of July using the information provided. The crop water stress index is 0.76. Okay. So how do we calculate crop water stress index? Is given as sigma of planting, harvesting, 1 minus TA by TP into sorry, into WCS, weightage factor. Okay. So in all these ones, the planting and harvesting is happening. So they have given CWSI is 0.76. So 0.76 is equal to 1 minus TA for May month is 2.5. TP for May month is 4.5 into weightage factor is 0.75 plus for June month TA is 2.2 by TP is 3.5 into weightage factor is 0.85 plus for July month 1 minus TA of July by TP is 3.3 into 0.65. So once you do the calculation, TA for July will be equal to 2.74 mm per day. If you remember, all the values are in mm per day, so the resulting value also will be in mm per day. Okay. So the next one is calculate the following NDVI ratios and comment on drought. So they have given the NDVI formula is NIR minus R by NIR plus R. Right. So for first one, NDVI is equal to NIR, reflectance in near infrared 0.55 minus 0.08 by 0.55 plus 0.08. That is equal to 0.6. Sorry. So that is equal to 0.47 by 0.63. So once you do the calculation, you get a value of 0.74. And in the next place, NDVI is equal to NAR, near infrared is 0.45 minus red is 0.4 by 0.45 plus 0.4. That is equal to 0.05 by 0.85 is equal to 0.06. So based on this, you can see that the if the NIR reflectance of in NIR is higher and R is lower, then we see higher NDVI value. Okay, and based on this table, so in first case, NDVI value is 0.74. That means, so where is it lying? It's uh, 0.74 means it is above 0.1. That means there is a above optimal condition, no drought. But in second case, there is NDVI being equal to 0.06. That means it lies in between minus 0.05 and 0.1. That means there is near normal condition. That is normal condition is the case in the second one. Okay, the next question is long-term maximum and minimum NDVI for August month are 0.75 and 0.03. The average NDVI for the month is 0.35. Calculate the vegetation condition index. So VCI is given as NDVI J minus NDVI minimum by NDVI maximum minus NDVI minimum into 100. So NDVI J is the average value of NDVI for that particular month. So VCI is equal for August month, the value is 0.35. And NDVI minimum is the long-term minimum for August month, that is 0.03 by NDVI maximum is long-term maximum for NDVI of August month 0.75 minus 0.03 into 100. That is equal to 0.32 by 0.72 into 100. So which is equal to 44.44 percentage. So if you see from this table, the VCI value is lying in this range. That means there is no drought condition. Okay. So these are the problems related to drought, and I have discussed a few questions also related to this. So if you guys have any questions, you can ask me. I'll wait for 1 or 2 minutes. If there are no questions, then we can end the session. So any questions? If there are no questions, we can end this session. Thank you for listening.